We are building a circuit that when we interrupt a signal, it will display it on the LCD screen. There are three interrupt signals we have connected in this. So first of all, we have done this code in Arduino IDE and uploaded its hex file into the official code. So let me explain the code. First, we have declared the main directories, the header files for the AVR code, which we are going to upload in this. Then we have used Arduino 2560 in this to compile and upload it. We have used several functions in one code. We have not used separate LCD module like we do in AVR. We have used these separate functions in one code that will enable us to generate just one file and upload it into this Proteus circuit. So to explain the code, first we have defined the LCD pins. We have defined the port A of the LCD. We have defined the DDR-A, DDR-C and port C2. We have defined the RS and EN. These RS and EN are the values of LCD. This is EN and this is RS. The RS needs to be low in order for the LCD to work, and EN needs to be 1. Next is the LCD CMD module. We have declared the CMD, the character type, into the LCD data port value, and LCD data port is port A. It is highlighting there. Then we have shifted the RS to the left side by 1 and stored it into this module. It is highlighting it. LCD control port is port C. Next is also LCD control port. We have shifted the EN value into the LCD control port. We have used the delay of microseconds, which is 1. We can increase or decrease this delay too, but it will make the interrupt getting condition very slow. Then LCD control port, we have used it to delay one. We have used the AND equal module in it. Next, the separate function is void LCD data. The void LCD data, we have used this LCD data port. Previously we have stored the CMD in it. Now we have stored the data in it. We have assigned the unsigned character to data. Next is LCD sign port. Same we did for the previous thing. We have used this RS data mode to store the value into control port. Next is delay 1 microseconds LCD control port. Same like we did in the previous, but there's one difference that we have used the AND module in it, and here we have used the OR module in it. Next is LCD INIT module. It is DDR that we are telling that control ports are on 1. They are output, they are not input. Next is to enable the 8-bit mode. We have used the LCD CMD module. We have used this 0x38, 0x0C and 0x01 to enable the different functionalities of the LCD. Moving on to the int main function, we have assigned first of all these values which are of LCD. These values are of LCD. We have shown this. Then there is global interrupt signals. We have used this SEI function. We have called this function to do the functionality. It is stored somewhere in the file, in the header module we have used. Then is LCD INIT. We have used this function here. It will do all the following things which we have declared in this. Next we have used the continuous while. This is the main loop. It will stay here forever. And then there is interrupt. We have used interrupt with the interrupt name interrupt 4, interrupt 5 and interrupt 3. We can use this to do this interrupt 1 and interrupt 2 and interrupt 3. We can do this. Okay, so when we change this here, we will also change this here. This will enable us to do the working properly the int module. This is interrupt 1 like we have used here. This is interrupt 3, 2 and this is 1. How we are assigning it, we have used first in 3, then we have to use 2 and then 1. So these are the commands that when interrupt is triggered, LCD CMD triggered, it will take this data that it is high, and it will go to this function LCD CMD. LCD CMD is over this function. This function has unsigned character CMD. That CMD means that we have 0x01 of interrupt 1 value, and it has gone here, and it will do this things in the LCD to show that it is that interrupt 1 is triggered. Next is in 2. This is the interrupt 2 signal. We have used this same thing here. The data is INT 5. It is written 5. We can write here 2, we can write here 1, and we can write 3 in the next. These are the pins which we have connected. First is connected to pin 2, then it is connected to pin 3, and it is connected to pin 18 of the interrupt signal, as we are seen here. So when we compile the code, it will compile like usual, but to upload it into Arduino, which we have used in Proteus, we have to export its hex file. To export its hex file, simply go to sketch, export compile binary. It will export a hex file in the directory which you have saved your program. Next is Proteus file. So let's see the connections of LCD first. In LCD, we have to use a potentiometer. And what does a potentiometer do in the real life? It will increase or decrease the brightness of the LCD. It is that 5 volt is given here, a ground is connected here, and the output is given to VEE file, which we have connected to 3 VEE. And what does it do? It not only powers, it limits the power going to the pin 3. And limiting power means that we are lowering its brightness based on the potentiometer. I don't think it will show correctly in Proteus, but in the real life we adjust the brightness of LCD with the help of Proteus. Next, we have used this universal ground, and we have connected this ground to at 2 places. One is this ground and one is pin 1 of it. We have given 5 volt power supply to VDD. This is the VSS of the LCD. We have to give power here, RS and REN. In this, we have seen these two are the we can say universal ports of the LCD, and we have declared this in our code. As you can see here, we have defined these 2 pins here. Next, we have connected the 8-bit value into this separate. We have started from 22, and we goes all the way around to IO 29. And if you see that this is the PA of a port A of our code, and when we have declared this in here, as you can see, LCD data port, we have used port A and DDR A. And to connect the output, the int 18, let's say we have used int 2, so we are using int 18 PD3 for it, and we are using these 2 pins here. These are PE4 and PE5. We have used this in our code to better define it, why we have used it. And let's upload the code in this Proteus. This is the X file of our Arduino. I previously uploaded it, so here we upload it again, and when we run it, it will show blank. The reason is that these 2 interrupt signals are not triggered right now. So first we are triggering this, it will show interrupt 3. We have seen that this is interrupt 1, this is interrupt 2, and this is interrupt 3. So this is 3. As you can see, this is the interrupt. So right now it will show like this, that if we trigger this interrupt signal, it will show IN3. If we trigger this signal, it will show interrupt 4. I changed this into interrupt 4 and this into interrupt 5. If we trigger this, it will show interrupt 5, and these 3 pins are connected to IO3, IO2, and IO8. These 3 are our interrupt pins. We have used this I first is this, wait a second, IO3. This is interrupt 5. IO2 is our interrupt 4. These are the default pins of our Arduino, so you cannot rename it. We can rename it in the code, but we have to display that which interrupt signal is being triggered right now. So interrupt 18 is our interrupt 3 signal, so we should display this on the screen rather than interrupt 3, 2 or 1. Okay, so this is our circuit and this is our code running. When we trigger a pin, it will show us that this interrupt is being triggered right now. So that is our code, and that is our Proteus circuit, and that is our code. I changed one thing in it. I changed this to default in 3, in 4 and in 5 because these are the default values of Proteus and we cannot rename this int 5 or int 4 or the default values int 3. We can however connect it to pin 19 and 20. They will be interrupt 1 and 2, and we have connected it to interrupt 4 and 5.